All right, here's our video today. High school geometry we're doing circles. Those pesky round things. And we should define a circle. So in this video we'll define a circle, which I'm sure you know what a circle is. Then we'll talk about the parts of the circle, and then we'll do the equations of the circle for this one. For this video. So what is a circle? Well, we know it's two-dimensional. And it has no straight line. So let's write some stuff down. So we know we can say it's a non-polygon. It's a non-polygon. Because polygons are shapes with no curves. And we know that a circle has a curve. It's a curved shape. So we know it's a curved shape. But what about that curved shape? Well, we know it's two-dimensional. We'll say it's 2D. It's two-dimensional. But that curved shape has no straight lines, like I said. So it has no straight lines. The only straight lines you'll see is when we talk about the parts inside the circle. But the shape itself has no straight lines. And it has a continuous boundary. Continuous boundary. And that boundary is called the circumference. So we'll say the continuous boundary, put a little arrow there, that's the circumference. And our C got a little smudge there. The circumference, this around the circle. We go around the circle, that's our circumference. So let's look at the parts of our circle. And we could let's start with the chord. There's the chord right there. So a chord is a line segment, and that line segment has two endpoints right here. So here's an endpoint here, and there's an endpoint there. So a chord must touch two endpoints in the circle, and it could be anywhere. I can make a chord, I'll make another chord, I'll make a chord there. There I go, making another chord, right? So you can continuously make chords. Yeah, I'll make another one. There's another chord. It's a line segment. It has two endpoints that touch the circle, that touch the boundary. Now here's something about the chord. As it gets closer to the center, right? As it gets closer to the center. If you keep moving the chord closer to the center, here I moved it closer to the center. Let's move it closer again. You'll notice something as you move it closer to the center. It gets longer until it reaches the center. And as you can see, this diameter is a chord. Right? The diameter is a chord, has two end points. It's right in the center, and it's the longest chord. So the diameter is the longest chord. So should we write down chord again? Let's write this down. It's a line segment with two endpoints. And those two endpoints must touch the boundary. And of course we know the diameter, like I said, is a chord also. Diameter is the longest chord. Again, as the chord gets closer and closer to the center of the circle, it'll get longer. Now let's look at the tangent. Let's clean this up for a minute. By the way, the area inside a chord is called the segment. So you can see this area I'm shading in over here. This is the segment. The segment is the area in a chord. So we know a diameter cuts the circle in half, so the area will be a segment. There's a segment on the top and there's a segment on the bottom. So the segment is the area in the chord. Now if you look at the tangent, say the tangent line, and you could see it, right? The tangent line is a line, right? It touches the circle at exactly 1 point. Only. So it touches the circle. We should say it touches the boundary of the circle at 1 point. And only 1 point. If it touches it at 2 points, then it's not a tangent line. And where it touches, let's just say it touched right there, that point right there, then we say that point is the point of tangency. So the point of tangency, what is the point of tangency, right? The point of tangency is where it touches the boundary. Right there. That's the tangent line. And of course, there could be many tangent lines on a circle. We'll talk about that in a minute. And that's an N, by the way. It's not an R. It looks like an N over there. So the point of tangency. So let's just make sure. Let's say, see this, the radius here. The radius is half the diameter. I'm sure we know that. We'll talk more about the radius. But this point right here, let's say we had a tangent line coming and it touched right there. Of course, we have to pretend that the line is straight. You could see something, right? So we know that this point, and we'll change the color. This point right here is the point of tangency because it's touching the boundary at 1 point. And you'll notice that the point of tangency and the tangent line, the radius coming out and the tangency, point of tangency, are perpendicular. So we know that if we draw a radius coming from the center, and of course all radii must come from the center, and it's drawn to the point of tangency, it will be perpendicular. So we know we're forming 90 degrees. All right, well, let's talk about the radius for a minute. So the plural of radius is radii. So with two I's there. And the thing about the radius is that it's always from the center, it's half the diameter, and you can draw any radii from the center as long as they're straight lines, and they will be equal. Right? Of course, my lines are getting a little crooked here, but I'm sure you're getting the point. You just keep drawing them. In fact, if I drew them, if I used a ruler and they were all the same length, which they have to be, you'll notice that if you kept doing this and you did it correctly, you will just eventually make a circle anyway. Just keep going and keep going, right? Again, all radii are the same distance. And if you have two radii, like you're seeing here, these two radii here, we have two radiuses, plural radii, and the area inside them will be the sector. So the area of a chord is a segment. The area inside this angle we formed, which is called the central angle, is the sector. And we know circumference. It's the distance around the boundary. It's the distance around the circle. So we have two more definitions here. We have to talk about the secant and the arc. Let's clean this up. By the way, you'll see we know that the radius r, we know it's half d. It's half the diameter. Now the secant, notice the secant. It has to touch the radii in two places, and it must cut. It must cut through the circle. As you can see, it's doing it. So the secant cuts through the circle. The Latin word secant, anyway, it derives from to cut. So it's cutting the circle. It has two endpoints, but the line goes through the circle. And again, the tangent, it only touches at one part of the circle. There's the point of tangency. And in Latin, the word derives from touching. That's what tangents come from. Now, the arc, I'm sure you're seeing the arc. So if we make a central angle, right? I'm just making an angle to the arc, trying to anyway. Let's say we make this. We have two radii, we should say two radiuses, plural radii, and we made a central angle, right? So think of a slice of pizza. That's the central angle. It has the center, the vertex in the center. You've made a slice of pizza. We know the area inside is called a sector. And the crust of the pizza is the arc. And we can find the arc length, which we will in other videos. So we have the parts of the circle. Now let's look at the equation of the circle. Okay, and you can see here's our circle. We have a center. And sometimes you see the center is just called O. Sometimes it's just called G. It could be called any letter. But we'll say center at O. So the coordinates of that center, the point, is usually listed as HK, where H is X and K is Y. So here's the equation. This is the general equation, right? The equation of a circle. And it's going to be X minus H squared. And by the way, they give you references when you're doing tests on this, so you don't have to memorize it, but you probably will anyway. You'll just do it as you keep looking at these. So we'll try to explain this. It looks fancy here. It's kind of looks complicated, but it's not that. And we know that HK is the center. So let's give an example. Let's say we wrote, let's say, x minus 3 squared plus y plus, could be any numbers. Let's put a 2, why not? 2 squared. And we'll say it equals 25. Well, now we know that the center is. It tells us right here. The center will be the opposite numbers, the inverses of the numbers. So see, it says negative 3. So we're going to say the center is going to be 3, because it's opposite negative 3. It's the inverse. And of 2, we'll say negative 2. So now we know the center. This center is 3, negative 2. So if it was on a plane, the coordinate plane, it'll be at x at 3 and at y at 2, negative 2. And the radius, well, we know the radius. It's been given to us as 5, but what's this 25? Well, remember, it's radius squared. So we know that 5 squared is 25. So just by looking at the equation, you can tell the center and what the radius is. So let's try another one. Let's clear this out. So let's keep the same radius at 5. We know the radius is 5. And let's say you knew the center. How would you write the equation? Let's just write anything, right? I'll write 4. Let's write 4, 5. Why not? How would you write that equation? Want to pause the tape or keep going? So we know the equation is x minus h. The h is the x. So we're doing the opposite. If it's 4, we have to say negative 4 squared plus, and they'll do the y part, not port. What do you think the y is? Be negative 5, doing the opposite. And of course, we know the radius is 5, so it'll be r squared is 25. So there's the equation. We just we wrote the equation. All right, let's do another one. All right, change the background. So what do you think this equation is? Give it a shot. Pause the tape, give it a shot. Or not. By the way, we should get our center going over there. Of course, we can call it anything. We can call it O. Sometimes you see it as G. Sometimes you see that. All right, so we have X. What are we missing? We only have the radius. We don't have any points. So how are we going to make a center? We can't. You need more information. But what you have here is you got, again, x minus h squared plus y minus h squared equals now not 15, but 225, because 15 squared is 225. Now, if I told you, let's say that the center was at -7, -3, how would you write that now? Now we have x. Instead of -7, we're doing the opposite, the inverse. We'll say +7 squared. And then we have our y, and we'll do +3, doing the opposite. And it equals 225. There's our equation. Okay, and another question you can get is if a point lies on the circle, on the boundary. Right, so we'll call this O. Oops, we went back to the old one. Let's go back. So again, they can call the center anything. We'll say the center is O. And let's say the coordinates of that center was, let's say it's 1, let's say 1, -2. And let's say we have a point A on the circle, remember, on the boundary. And then we want to know if another point, let's say we'll call it B, we want to know if this point B lies on the circle. And let's say we're given these coordinates of the circle. We'll say we're given the coordinates, well, let's say 4 and 1. Does 4, 1 lie on this boundary? Well, we'll make our equation, right? We know our equation already. We have our x. What do you think it will be? Well, it's not going to be +1, it'll be -1 because we're doing the inverse. And what do you think about the y? You got it, +2, doing the inverse. And we know it equals 25. So now we want to know if this point, B, lies on it. So we'll replace the x's and the y, the x and the y, with these coordinates. So now we'll say 4 minus 1 squared, that's the x, plus, what do you think the y is? 1 plus 2 squared. And if this equals 25, then it will lie on the boundary. If it does not, then it won't. So 4 minus 1 we know is 3. 3 squared is 9. 1 plus 2 is 3. 3 squared is 9. 9 plus 9 is 18. 18 does not equal 25. So 0.41 does not lie on the circle. And we're talking about the boundary. Alright, so that's our video today, just talking about the parts of the circle and the equation.